We're going to talk about Bohr Rutherford diagrams in this video, and probably did it in grade 9, but if you didn't because of the lockdown or because you did it first semester and you have no recollection, that's okay. We're going to go through this. I apologize for this terrible quality video. I can't figure out the lighting. I can't figure out how to get this camera to be any sharper. Well, I can, but then the computer won't work with it. So we're just going to have to struggle through this. Again, if you have any questions, just email me. So if you remember from drawing your diagrams or from your atom diagrams, we've got protons in the center, we've got neutrons in the center, we've got the electrons that are circling around the outside. So let's try to draw some of these Bohr Rutherford diagrams. We'll do the whole chart because we want to look for patterns. Now I filled a whole pile in for you because in grade 9 you should have done this. We'll do the ones together. Again, if you want to watch and then do it on your own and come back and check. If you want to do it as we do it, that's fine. Stop the video whenever you need to. You just work at your own pace. So for our first element here, we're going to have hydrogen. So our hydrogen is atomic number 1, right? Its symbol is just plain old H. And in the center of it, I know it's a little bit tough to see because of the lighting. I'm trying to change a little bit, but it's not going to help. I'm telling you now. Anyway, in the center of the atom, we have 1 proton. Now, in order to find out the number of neutrons, we take the mass, and for hydrogen, the mass, if you've got your periodic table, you'll notice that the mass for hydrogen is 1. All right, so 1, the atomic number minus the atomic mass is going to give you a number of neutrons. So 1 minus 1 is 0, so we don't have any neutrons here in hydrogen. Now, I'm going to make you, I think we already did in the other video, make sure you put your electrons in the proper order, how I show you to do it, because it makes life so much easier later on in chemistry. So we've got 1 electron up here. Great. Let's hop over here to helium. So helium is number 2 on the periodic table. Its symbol is He. Right, so that 2 tells us we have 2 protons in the center of the atom. Its mass is 4. We'll round it to 4. So we've got 2 neutrons in the center. Sorry, I wrote down 4 because I was so excited about the mass. All right, and so around the outside we have 2 electrons. In that inner energy level, we do 1 and then 1 at the bottom. All right, because it just shows us that that whole energy level is full, and these 2 electrons, because they're negatively charged in this energy level, they're as far away from each other as they possibly can be. The second energy level has a little bit of a different shape to it, so even though we draw the electrons close to each other, they really are far away. One's above the level and one's below the level, so to speak. So let's go to our next guy. We've got lithium here. So our lithium is atomic number 3. Symbol is Li. Remember with these symbols, the first letter is always capital, the second letter is always small. So we've got 3 protons here in the center. Its mass is rounded to 7, so we've got 4 neutrons. And we're going to fill in 1, 2, and then we're going to have our 3rd electron around the outside. All right, so if we follow along here, for our beryllium, we've got 4 electrons in the outside because we've got 4 protons in the center. So we've got 1, 2, 3, 4 around the outside. Alrighty, and this outer energy level now has 2 electrons. We've placed 1 here and 1 here. For our boron, we've got 5 protons, which mean we have 5 electrons. 1, 2, 3, 4, 5. All right, and we've got 1, 2, 3 spaced away from each other in that outer energy level. Carbon was done for you. Same thing. We're up to 4 now. 1, 2, 3, 4. We get to our nitrogen. We've got 7 protons. 1, 2, 3, 4, 5, 6, 7 electrons in the outer energy shell, or the outer energy levels. And that outer energy level has got 5 in it. If we get to our oxygen, we've got 8 protons, so 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. All right, let's try fluorine. So with fluorine, we've got 9 protons. Okay, we've got 10 neutrons because its mass is rounded to 19. All right, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons in the outer energy level there. All right, so notice here we've got 1, 2, 3, 4, 5, 6, 7 around the outside. With our next guy here, our neon, we've got 10 protons. its mass rounds up to 20, or rounds to 20. So we've got 10 neutrons. So therefore we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, now that's a full energy shell. We've got 8 electrons in the outside. This is a full energy shell. It's got 2 electrons in the outside because it's the first energy level. Our third energy level here, nice and full, it's got 8. So there's this thing that's called the octet rule. This is going to be really, really important. So the octet rule says that an atom is going to try to get 8 electrons in its outer energy level. I'm writing on a box, so it's kind of scratchy sounding. All right, with the exception of helium that tries to get 2. So this is what's going to happen. This makes it very, very stable. So these atoms are stable. These are the ones, if you remember from the families video, they don't blow up, they don't react, they don't, react with acid and water and all sorts of stuff. Scientists can make them react in the lab, but of course they're manipulating things around. But in natural circumstances, these things don't do anything crazy. Oh, I forgot to put down that this was neon here. So 10 and neon. Alrighty, because they have satisfied, their outer energy levels are satisfied. They're nice and full of electrons. Alright, look at 11. I don't need to count that out for you here, but we see there's 1 electron in the outer energy level. We see there's 2 here. So let's do our aluminum, which is number 13. Right, we have 13 protons in the center. I think we have 14 neutrons in the center. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now remember, we draw these side by side, but one is actually high above in the top of the energy level, and one's way, way, way below. So they're really not close to each other. We just draw them that way because we're drawing a 3D atom as 2D. All right. So then we have 1, 2, 3 around the outside. So we have 3 electrons around the outside. Silicon here, we have 4. We've got 1, 2, 3, 4 electrons around the outside. With our next guy here, 1, 2, 3, 4, 5. Next guy here, 1, 2, 3, 4, 5, 6. Next guy, 1, 2, 3, 4, 5, 6, 7. Next one, I can just tell you that it's 8. All right, then we start back over here to this next period that's here. And look here, we only have 1 electron in the outer energy level. So let's try to do this last one together, and you can try to figure out, I wonder how many electrons are in the outer energy level before you even start. All right, so this one here is 20. This is our calcium, really important in our bones and our teeth. So we've got 20 protons here. We've got 20 neutrons because its atomic mass is 40. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 11, 12, 13, 14, 15, 16, 17, 18, and if you said there's going to be 2 electrons in the outer energy level, you would have been very correct here. Alrighty. So now the next thing I want you to do with this, which you probably did in grade 9, but that's okay, we'll do it again, is we're going to number the columns, all right? So this here shows, because we're only worried about the first 20, so this line here shows you the division between the metals, so that our metals are over on this side and our non-metals are all over here, okay? And all those crazy elements that were in the center of the periodic table, we're not going to worry about those right now. Things kind of go amok when we include those with this simple stuff here, so we're going to kind of ignore them for now. Alrighty, so this would be family number 1. This is going to be 2, and because we've skipped out that middle thing, this is going to be 13. Alright, 14, 15, 16, 17, and 18. Alrighty, and then we're going to number the periods. This is period 1, period 2, period 3, and period 4. Alrighty? And remember from our families, these guys all have similar properties to each other. Alrighty? So we've got a lot of similarities down this family. This is like you and your family. Maybe everybody has blue eyes. This family here, everybody is pretty reactive with water in here. And remember, poor little hydrogen, he's out on his own. All right, now, what do you notice about the number of electrons going down the family and the family number? Well, Look at here. We've got one outer electron here, one outer electron here, one outer electron here, and one outer electron here. So everybody in group 1 has one outer electron. Ooh, let's go to number 2. See, if we were in class, I'd be like, what do you think about number 2? So if you take a peek here, everybody here has 2 electrons in their outer energy level. So for these guys here, the group number tells you the number of electrons in the outer energy level, and that's really important when we get to bonding. Now here we have group 13. All right, what do you notice about the number of electrons in the outer energy level of group 13? Well, someone will say 13 to me, but in class, but we're so smart now, we notice that there's 3 electrons in the outer energy level. Group 14, 1, 2, 3, 4, 1, 2, 3, 4. 15, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 16, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. All right, 17, I'm going to let you take a guess at how many are in group 17. Hope you said 7. And group 18, I hope you said 8, with the exception of, whoops, our helium here. Okay? Now, if we notice as we go along here, too, we've got our number of our periods. And if you look across here for period 1, how many energy levels do we have? We have 1. Alrighty? If we go to period 2, how many energy levels do we have across here for period 2? We've got 2. Okay, sorry. If we go along here to period 3, how many energy levels do we have here across 3? And here for group or for period 4, we've got 4 energy levels. So those are some of the trends. Now, in chemistry, we always say opposites attract. So we've got metals on this side and we've got non-metals on this side. The metals, as we go down, if you notice how big the atoms are. So it's pretty hard for this little positively charged nucleus to hang on to this one little electron that's way on the outside. That's going to come out to be really, really important for bonding. Right? It's like if you go to the mall, your mom, you've got 19 kids to take care of. All right, the one little straggler at the back, chances are that little kid's going to get left behind. So it's the same kind of thing here. This little straggler out here, it's really hard for that nucleus to hang on to that, especially since it's such a gigantic atom. It's really, really spread out. So this can tend to be given up very, very easily. Now, if you have something like this over here in the nonmetals, and it's got 7 electrons around the outside, it wants to have 8, all right? It would be easy for something that's a smaller atom like this, that's got 9 positive protons in the inside, it's got all these electrons gathered really, really close to it around the outside. Wouldn't it be easy for that fluorine, oops, forgot to tell you it was fluorine, for that fluorine to snatch that electron away from this potassium over here? All right, that will fulfill this and make this have 8 electrons in its outer energy level if there's another little one in here. And that will fulfill this one too, because if it gets rid of this one here, then there's 8 electrons left in that outer energy level. Now, that outer energy level, we're going to give it a little name, okay? So the valence shell, or the valence energy level, or the valence energy level, all right, oops, is the outermost energy level. All right, so if we talk about the valence shell or the valence energy level, it's the outermost energy level. All right, because this is where all the reactions are going to come from. These little guys that are all satisfied in here, that satisfy that octet rule, those electrons aren't going anywhere. They're perfectly happy in their little home. All right, the valence electrons, we're going to talk about valence electrons. You're going to be so sick of this wordy valence by the end of this whole course, but it's going to be the rest of your life. You have to use that word valence. So the valence electrons are the electrons in the valence shell. Okay, so if we talk about valence electrons, we're going to talk about the electrons that are in that outer energy level, or the valence shell. Hugely important. One little trend I want to write down here too, even though we talked about it. So as we go across the periodic table from left to right, so left to right, Okay, we notice that the number of electrons, I'm just going to do a little symbol for electrons like this, increases. All right, so as we go from left to right, we've got 3 electrons here, we got 4 electrons here, we got 5 here, 6 here, 7 here, 8 here, 9 here, 10 here. So the number of electrons increases as we go across the periodic table. All right, and as we go from top to bottom, all right, our number of energy levels increases. Okay, so make sure you keep this in your notes. I'm going to refer back to it on the next level, the next video, because we're going to be talking about Lewis diagrams, which are a lot easier, and then from our Lewis diagrams we're going to go into forming ions when we're losing or gaining electrons, which we just talked about here. And if we form ions that have opposite charges on them, which we're going to get into, we can actually form compounds from that. Alrighty, so I'll see you on the next video.